This is a specification of the Probit model with only one regressor X. On the left-hand side of the model, we have the conditional probability of y equals to 1 given X. On the right-hand side, we have the outcome of the cumulative standard normal distribution function, or the CDF function of a standard normal distribution, with beta naught plus beta 1 times X as the input variable. As shown in this specification, the Probit model is no longer linear. It's no longer linear in the X variable, and it's no longer linear in the coefficients. The input variable for the CDF function is usually referred to as a z-score. In this case, beta naught plus beta 1 times X is equivalent to a z-score. Based on each z-score, the CDF function computes the probability of a given z based on the standard normal distribution. Since the CDF function computes probability, therefore the predicted probability on the left-hand side given by the result of a CDF function is bounded between 0 and 1. Moreover, the CDF function is increasing in X if beta 1 is greater than 0 and decreasing in X if beta 1 is smaller than 0. And these attributes describe the conditional probability of y equals to 1 given X on the left-hand side of the equation very well. And hence, when it comes to fit a model with binary dependent variable, we think of the Probit model as the natural choice. If we fit a Probit model on the scatter plot, the fit is captured by this red line. As you see that the relationship between the probability of mortgage application denied and the PI ratio on the x-axis is no longer linear. It's captured by the CDF function that is bounded between 0 and 1. This fit looks much more realistic than the fit of a linear probability model. To estimate betas in a Probit model, we need to use the GLM function in R. GLM, standing for Generalized Linear Model, is commonly used to model binary or multinomial data. When you use the GLM function in R, the estimation of parameters is done using the maximum likelihood method, or MLE. In the first argument of the GLM function, you specify regressing y on X, as before. In the second argument, you specify that family is equal to binomial, because in this case, our outcome variable is a binary variable. Within the parentheses, you will specify link is equal to Probit, indicating that you're estimating a Probit model. If you don't specify a Probit model in the second argument, then by default, GLM will estimate a logit model for you. Additionally, now that our model is estimated using maximum likelihood, we don't worry about controlling for heteroscedasticity anymore. Therefore, in the Stargazer function, you can set the standard error to null for all the regressions you run. No more CSE function to compute heteroscedastic robust standard errors. Here is the output for the Probit model. In model 1, I regress denied on the black dummy. In model 2, I regress denied on black dummy and the PI ratio. In this case, since the model is no longer linear, the coefficient estimates that you see in this table no longer give us the answer for the marginal effect of X on Y. However, you can still perform inference tests, such as t-test and f-test on these coefficients as usual. Why? Because these coefficients are estimated using the maximum likelihood method. We'll explain the inference under the MLE framework in greater detail when we go over the properties of the MLE estimators in the later slides. For now, just remember that you can still perform t-test and f-test on betas in the Probit models. The summary section only reports the number of observations and the log likelihood for each model. Since the parameters are estimated by maximizing the log likelihood, higher log likelihood means the model is better. Now, how do we measure the marginal effect of X on Y in a Probit model? We can evaluate the marginal effect of X on Y based on a specific value for X. For example, how do we measure the effect of race on the probability of rejection? The left-hand side of the Probit model is a conditional probability of application denied equals to 1 given PI and the black dummy. The right-hand side of the Probit model is a CDF function with beta naught plus beta 1 times black plus beta 2 times pi as the input variable. Therefore, if we choose a value for pi, say 0.3, then we can evaluate the marginal effect of race on the probability of rejection when pi is equal to 0.3. Specifically, we'll first compute the result of the CDF function when the black dummy is equal to 1. By plugging in the value of 0.3 for the pi in the CDF function, the result gives 0.23 or 23%. Next, we'll compute the result of the CDF function when the black dummy is equal to 0. Again, evaluating at 0.3 for the pi in the CDF function, the result shows 0.075 or 7.5%. Taking the difference between the CDF function when black equals to 1 versus when black equals to 0 gives 0.155 or 15.5%. This number means that on average, a black applicant is rejected 15.5% more often than a white applicant when the pi is equal to 0.3. Instead of computing the marginal effect by hand, we can use the R package to evaluate the marginal effect for us. There are two different ways to evaluate average marginal effect in R. The first approach evaluates the marginal effect of x and y at the mean of each x variable. The second approach evaluates the marginal effect of x and y at each value of x and then takes the average of all marginal effects across the board. Let's see how we can implement both approaches in R. To evaluate the marginal effect for the Probit model, you need to install an R package called error. Within this package, you will use the Mabina function to evaluate the marginal effects for all the regressors in the Probit model. To evaluate the marginal effect for the first Probit model, you will assign pi to the Mabina function. Pi is the first Probit model with only black as a single regressor in the model. X.mean equals to true means that you are going to evaluate the marginal effect following the first approach to evaluate the marginal effect of x and y at the mean of x. Ref.dom equals to true means that there is a dummy variable in this regression, and you want R to treat a dummy variable differently than a continuous variable in this model, and retain 3 digits for the results. Similarly, to evaluate the marginal effect for the second Probit model, you will assign P2 to Mabina function and everything else the same. Using the Stargazer function to display the average marginal effect for both models, we obtained this table. Now the estimated coefficients measure the marginal effect of each regressor in the model, and these numbers are now super easy to interpret. For instance, the coefficient for the black dummy is 0.191. This means that on average, a black applicant is 19.1% more likely to get a mortgage application denied as compared to a white applicant. The coefficient for the PI ratio in Model 2 says that by increasing the PI ratio by 10%, the probability of getting a mortgage application denied increases by 0.5 times 10%, or 5%. You can also evaluate the marginal effect using the second approach. That is, you will first evaluate the marginal effect at each value of x along the horizontal axis, and then take the average of all the marginal effects to compute what is the mean marginal effect. In this case, you are going to employ Mabina function. Now the difference is that you will set the x.mean to false. So R knows that you want to use the second approach to evaluate the marginal effect. To show you the mechanics of this approach, I used the MA trend function to plot the trend lines that illustrate the marginal effect of the black dummy on the probability of rejection. The top dotted line shows the probability of rejection when the black dummy is true, and the bottom dotted line shows the probability of rejection when the black dummy is not true. These trend lines are evaluated based on each value of PI ratio on the x-axis. Based on this plot, we see that when the PI ratio goes from the smallest to the biggest, the trend line for the probability of rejection when the black dummy is true constantly hands over the trend line for the probability of rejection when the black dummy is not true. This plot provides evidence of racial discrimination in mortgage applications. Now, if we take the average of all the marginal effects evaluated along the x-axis, we compute the average marginal effect based on the second approach. Now let's pause this video and do the in-class exercises 2 and 3. In summary, the Probit model uses CDF function on the right-hand side of the model so that the conditional probability on the left-hand side of the model is bounded between 0 and 1. The estimation is done using the maximum likelihood method, which we will discuss in detail later. The interpretation of the coefficients in a Probit model is not as straightforward as in the linear model, but we can employ R to evaluate the marginal effects for us. We can still do inference tests such as t-test and f-test for the coefficients in the Probit model.